No. Hey, how's it going?
What's this going on?
So I'm asking two very easy questions to see if people can get them right. They're multiple choice. You want to give it a shot?
What's the trick question?
No, not trick questions. They're very easy.
Okay.
Yeah, so right here I have 3 box trucks.
Okay.
And there's a bowling ball inside hanging with the string,
Okay.
you know? So one of these box trucks is at rest, one is accelerating forward, and one is accelerating in reverse.
Okay.
So out of these 3, which one is at rest? Yes, that's obvious, right? What would you say be them?
Because if it's accelerating forward, then momentum.
Okay, yeah.
Reverse.
Then it's the opposite. Yeah, you got it. Because it's not moving. It's not, you know, it's staying plumb, you could say. So which one would you say is accelerating forward? It's A, obviously, right? And it's obviously because the ball appears to swing back. Well, the force is going this way, but because of inertia, the bowling ball remains in its position in space. So you could say that it's being left behind.
Yes.
So the whole container is moving forward, but the bowling ball is being left behind. Yeah, you got it. So the second one is pretty similar. Here we go. It's pretty similar, but instead of a bowling ball, it's a helium balloon inside the box truck, right? So out of these 3, which one is at rest?
Should be B.
It actually is.
Okay.
And it's for the same reason as the first one. It's because it's not reacting. It's still remaining plumb, you could say, or vertical, right? Which one's accelerating forward?
If I take the bus going east of here, it's worse. That's where I'm supposed
I mean,
to
because it's tied to the ground, I would say it's A.
You think it's
If it
A?
wasn't tied to the ground,
Oh, really? You think so? Oh, it's actually C.
okay.
So the reason is C is because helium is less dense than the air that's inside of the box truck. So when you accelerate the box truck in that direction, for example, all of the air inside of the box truck is also being pushed in that direction, you know, by the back wall of the container.
That's true. When you move forward,
All of the air inside, yes. So because air is more dense than helium, is able to push it in that same direction that the force is being applied.
okay.
Yeah. So again, I have a demonstration here of that. So
Is that a helium then?
no, this is a buoyant object. So that's what buoyancy is, in other words.
Oh,
It's the medium that surrounds it being more dense, pushing on the less dense object, right? So here we have a buoyant object inside of water. So the water is more dense than this red ball, right?
Okay.
If I accelerate in this direction, what direction do you think the ball's going to go? Yes, it's going to go in that direction. See? It gets pushed in the direction of the force.
So initially it goes that way, and then because of like equal force, it goes back after.
He goes back after because I'm not accelerating anymore. But if you continue to accelerate, it's gonna remain in the front if you continue that acceleration. You know, because
I'm not smarter than a 5th grader.
you are, trust me, you are. But yeah, so again, buoyancy is a chain reaction of a force, and buoyancy always follows the direction of the force, right? So pretty easy. So let me just show you this. I did this experiment myself, and I want to see if you can tell me. So instead of a bowling ball, I used an apple, and then I used the helium balloon. Obviously, they're both tied inside the box truck. But based on what we just learned or demonstrated, you would say I'm accelerating to the right. Exactly, yes. Because not only does matter show you the exact moment I accelerated, it shows you the direction I accelerated.
It definitely does.
It does, exactly. Because if I did it the other way,
Then
you
it
would.
would-
And you get the
reversing where
helium.
you're going to.
Yes, the helium. Because that's the helium will always react in the same direction the air's
less dense.
because it's less dense. Exactly. And again, and I did it with in a smaller scale as well. Here's a container filled with water and a red ping pong ball and a steel ball. So what direction would you say I accelerated here? To the right, exactly. Because that's the buoyant object is being pushed, you know, by the water in that direction, which means the water is also moving in that direction through space, right? So one last one. I did a vertical acceleration. So what that means is I had a water bottle like this, and I was just holding it, but I only accelerated one of these 2 down vertically. Which one would you say I accelerated down vertically? The one on the right?
Accelerated down.
Yes.
The one on the right.
Exactly. Because not only does it show the
Less dense one going down. But
Yes.
the more dense one going south.
Exactly. Perfect. So do you believe that if I was just to hold an object like this and not accelerate it, but just release it into free fall, do you believe gravity pulls it down towards the earth? Like it accelerates it down?
I know, definitely. But it
Right.
also has, because it's also dense enough that gravity
Yeah.
can act.
Okay, no, yeah. So here, the one on the left, I actually just released it into free fall. So this is free fall. But we see that matter didn't react to that acceleration. So I don't know if you knew, gravity is just theory. So they've never actually measured a force in free fall accelerating matter down. And matter shows that it doesn't react to that acceleration because there is no acceleration in free fall. And that's why gravity is just a theory.
How about this one?
So this one I physically accelerated with my hand. Yes, so this was a real physical acceleration. This was just free fall, which they claim is an acceleration, but matter shows that it's not being accelerated.
Isn't there also a force of gravity that's acting?
Well, that's what they say, that the force of gravity is grabbing all the matter together and accelerating equally. But that's like claiming that you can accelerate this way without any change. But that defies physics, because when you accelerate in any direction, you create pressure within the medium that's inside the container, whether it's air or water, and that pressure will push anything that's less dense in the same direction as the force. They're claiming that in free fall, something different happens that nobody can recreate or replicate. So this force field that they're claiming exists here on Earth, it actually doesn't exist. So the force of the Earth is not a pulling force, it's actually a pushing force. So
You say it's keeping the Earth, like, doing its Earth.
well, here's the thing. If we understand buoyancy always follows the direction of the force, right? Whether, in any scale, for example. If I have a helium balloon here on Earth, right, and I release it, what direction does it go? So what's pushing up the helium, do you think? What do you think is pushing up the helium?
Because it's less dense in the air.
Yeah, so the air is pushing it up, right? So we understand that inanimate matter cannot push itself, right? So in this scenario, it was the truck that pushed the air, which then pushed the helium. So what do you think is pushing up the air here on Earth that's pushing up the helium? Yes, exactly. So the fact is, it's the Earth that's pushing up right now, so it's not pulling you down towards the Earth. So the force of the Earth is a push, not a pull. So this upwards push of the Earth, it's what's compressing the air or pushing on the air, which is then is able to push anything that's less dense, like fire or helium or any lighter gases.
We're still like
Yes, because the Earth is constantly pushing up against it. We can't escape that push of the Earth. So when we jump, the Earth just catches up again because it's continually pushing. It's always pushing up.
Okay, that's pretty interesting.
Yeah. So here, let me tell you this. This is where I'm getting to. So you believe the Earth is a ball, right? Yeah, right? So you understand that on a ball, up is relative. So in other words, if you're standing here, up is this way, but if you're standing down here, up is in the opposite direction from here. And every direction away from the center will be up on a ball, right? If we could prove that the force of the Earth is a push, in other words, it's pushing up, moving up, how can the Earth move up in every direction at the same time if it was a ball? Yes. How can the Earth push up in every direction at the same time if it was a ball? Well, magnets only affect metal, and they kind of, they don't really push,
Could spin?
And the spin is not. Well, the spin would mean it's not moving up; it's just turning on its axis. The Earth is literally, if you're standing here, it's literally pushing up this way. But if you're standing down here, we'll have to be pushing down this way. So
It is spinning.
that's what they say. But here's the thing: if we could prove that the ground is literally moving up, and buoyancy shows us that it's literally pushing up, then it wouldn't work from a globe, because that would mean the Earth will have to be expanding to be able to push up omnidirectional in every direction at the same time, and it would just explode. So in order for people to believe in the ball Earth theory, they first have to believe in the theory of gravity being a pulling force, because if we could prove that it's the other way around, that it's actually pushing up, then the whole globe Earth model wouldn't work, not even on paper. So this will be the number one proof to debunk the globe, is that the force of the Earth is not a pull, it's a push. So again, the Earth is simply a level plane, and we're all standing on it, and it's literally just pushing up in one direction. So everybody's up is the same.
What happens to the ends of it?
So we're actually being contained somehow. So you understand that at sea level, there's 14.7 psi, right, of air pressure, and the higher you elevate, the more it decreases. But in order to maintain air pressure without losing any pressure, the air has to be physically contained somehow. So that's the law of entropy.
Yeah, the atmosphere.
Yeah, but the atmosphere itself has to be physically contained by a physical barrier. So they're claiming outer space is right next to Earth's pressure without a solid barrier separating the two. They're claiming that it's gravity holding the air from escaping into space. But that kind of force, again, they rely on the pulling force of gravity to explain away everything that doesn't make sense, for example.
But wouldn't the vacuum outside continue?
No, because like a vacuum would, you could say, the air would disperse into space if it was no solid barrier. It would just, because if you have, in order to maintain two opposing pressure systems next to each other, you need solid barriers separating the two. Like if you want to create a vacuum here, you need a solid cube, for example, and you got to suck all the air out, right? If you have a hole on that container, the air outside, the pressure outside, it's going to rush into that void to fill it, to equilibrate. So that's what air does if it's not being physically contained. So the claim that outer space is a vacuum next to Earth's pressure system without a solid barrier defies physics, defies the laws of entropy. You know, again, their explanation is gravity, which is just a theory. So everything about outer space, orbits, you know, how day and night works with the sun spinning, all of that relies on the belief of gravity being a pulling force, which can easily be debunked. And that's why it's the number one proof that debunks the globe, that the Earth is pushing up and not pulling you down.
How about when ships go?
Okay, so when ships appear to go over the horizon, right? You think that's the curvature obstructing, right? Yeah. So we actually do have a limit to how far we can see. So depending on how tall you are, obviously you could probably see a little further, and if you're shorter, you see a little bit. So there is a angular limit to how far light enters our eye. So when a boat simply, it appears to go over a horizon, it's simply going out of perspective. So it's going out of our field of view. That's what's happening. So
Short person and a tall person would still see that same thing.
they would see it, yes, because obviously a foot in height, difference in height is not going to make that much of a difference. But let's say you elevate 6 stories up, when the boat simply disappears from the person on ground level, if you elevate in a building, for example, that person will be able to see it because you're increasing your angle of view. So your field of view is bigger now. So it's not because of the curvature. Huh?
How about satellites?
So satellites, if you could look this up when you leave, try to look for a genuine photograph of a satellite in space. It doesn't exist. They're all CGI. So when you put satellite on Google and go to images, all of the images of the satellites are all cartoons. They're all CGI. So a satellite in outer space doesn't exist because, I don't know if you knew, over 97% of communication done here on Earth is done through underwater cables. So the whole internet system, everything is done through underwater sea cables and through ground towers. So that's how we do communication here on Earth. So any signals that are coming from above are, have you ever heard of satelloons? So they're giant helium balloons that Google and NASA put up there, and those are what the satellites are. They call them satelloons. Well, I don't know if that's the official name. I think it is. And ironically, NASA is the #1 helium buyer in the world.
I get your point.
Yeah.
But I just want to ask.
Yes.
If it is not blue, right?
Yes.
Why do flights go over the Arctic if you want to go, say, to Europe or something? Like instead of going straight, like from here, straight, like that. East. Why do they go over the Arctic, which is the shortest distance?
Right. I don't have a.
Theoretically, it would be the shortest distance.
Yeah.
Otherwise,
Well, first of all, the Arctic, the north part of the Earth, is actually very restricted. So it's like a no-fly zone. I think it's like 66 degrees north, or I don't know the exact distance north. Nobody's allowed to fly through the north. So I would ask why. Why don't they allow people to fly right over the north, right? So that's just a law that they implemented. That's why planes don't do that. But either way, flight paths would work on a level Earth regardless.
No, I'm asking why is the fastest distance and shortest distance going over the Arctic instead of going straight? Because theoretically, if it wasn't a globe, it would be going straight.
So explain to me, for example, here.
So you got point A over here,
Yes.
and you got point B over here.
Yes.
Right? Theoretically, if you look at it as not a globe, fastest distance would be going like this.
Yes.
Right? But why do flights go like this?
Well, flights do go like this, but they don't go exactly over the center because this area is
they don't go
restricted.
over the
But they
center,
do fly
but
like
they go
this.
like this.
Even if it was a level Earth, for example, like this, it would say the north is right here, right? And the continents, instead of being around a ball like this, they're just spread out like this. So if you're down here in America and you're trying to fly across the other side of the Earth, I would call it the other side of the pond, you're simply just flying like this. Instead of going like this, they fly like this.
Then if
They don't go around like this, they fly in straight lines.
then
So
what,
from here to
what
here.
would be the explanation for the Arctic and the Antarctic?
So the Antarctic, the magnetic South Pole hasn't never been proven. So nobody's actually gone to the South Pole and used a compass to say like, oh, we're at the geographic South Pole. So nobody's actually done that. So what's going on in the South? Nobody actually knows. Maybe the government does know, but they're just keeping that from the populace. But the North Pole, obviously, you know, anybody can verify with a compass that there is a geographic north or a magnetic north, in other words. But a South Pole has never been proven. Yes, people go to Antarctica, they go to a ice sheet somewhere. I don't know where that ice sheet is in relationship to all the other continents. So I don't know exactly where they're going. And the fact that they've never pulled out a compass to show on camera that they're at the South Pole should obviously raise a lot of red flags. That video doesn't exist. You know, here, let me ask you this. Do you know the radius of the Earth they tell us? So the radius of the Earth is 3,959 miles, which is obviously the distance from the center to the surface. So based on the radius, we can calculate for the circumference, which is 24,901 miles. Okay. So you can verify this for yourself, you know. Based on the radius of the Earth, they tell us there has to be curvature every mile, and every mile it has to increase. So it comes out to 8 inches per mile squared. So that means in the first mile, there should be an 8-inch drop of curve. In 2 miles, there should be 32 inches of curve, and in 3 miles, there should be 6 feet of curvature. And in 10 miles, there should be 66 feet. So it just keeps increasing more and more. So how do we measure for that curvature, right? There's a very easy way. If we went out to a giant lake that was miles across, with obviously water filled, and once it's at rest, if we build a level structure over that body of water, we'll say 3 miles across, the surface of water is going to remain parallel to anything horizontal above it. Because once water's contained and at rest, it always collapses and forms an equal surface, which is level, which is horizontal. They're trying to tell us that the surface of a lake that's 3 miles across, it's bending 6 feet in 3 miles. So if we build a level structure over the lake, they're trying to say that the gap between the level structure and the water is going to increase from the starting point to the end point by 6 feet. So that's how much water curve they're claiming should be there in 3 miles. Not only that, they're claiming 66 feet in 10 miles, which is like a 6-story building of curvature, but the physics of water doesn't have the ability to form any shapes on the surface once it's contained and at rest. So the physics of water debunks that there is any curvature of the Earth, regardless of distance.
On the top of the water, then how the water bodies?
I'm sorry?
On the top of the water,
yes.
how the water bodies?
Water buildings are connected?
What is it?
You're talking about how all the oceans connected? Well, I would say the oceans are no different than a lake in the sense that they're just giant craters. So obviously, the fact that they're connected, there's obviously no lands in between them to block them, to separate them from each other. So that's why they're connected. It's just like a giant crater. You know, that's what the oceans are.
How are we constantly saying the bottom to the top, but the other way around?
I'm sorry, what was it?
If you go from, say, the Indian Ocean, where you go all the way down, and then you go to the Arctic, but you can just, if on a globe, you can just go like a few, but like on the...
Well, on a level surface, put it this way. The oceans, again, like I said, it's just like a giant lake, and all the continents are just spread out, you know, across the way. So you just travel in any direction and you'll get to where you need to, you know. It's no different. You just think that you're going from like the top of the globe to like the bottom of the globe, right? But in reality, you're just going from the center to the outer circumference. That's what's happening. So instead of, again, you thinking you're going from here down here, you're simply going from here across the way, just south, but across the way. You're not going down under a ball.
So you just kept going?
So if you kept going south, for example...
This way? Yeah.
Yes. Okay. If you say this is the north, right? And if you just kept going south, in my opinion, you reach the end of the Earth. So there is an end to the Earth. It's not infinite. So they're claiming that you'll just come back around this way. But nobody's actually ever done that. Nobody's gone south and then came back up around. That path has never been done before or recorded or anything. You know.
Pretty sure it has.
It actually hasn't.
I'm pretty sure it has.
You could look it up. It actually hasn't. I think there was somebody that claimed to do it, but there's no actual physical evidence to back up that claim. I think there's someone that claimed to do it, but other than that, there's nobody's ever done that path. Because, well, in my opinion, again, if you just go south, you're going to reach the container of the Earth, in my opinion. Because, have you heard of the Antarctic Treaty? So over 57 nations have signed the Antarctic Treaty, which prevents any independent exploration of Antarctica, or in other words, south. Nobody can independently explore south if they wanted to. So let's say I was a billionaire or a millionaire, and I just had free time and money and resources, and I wanted to find out what's actually south, I wouldn't be allowed. The governments wouldn't allow it. There's a treaty. You could go to jail, if you try it. So you got to ask yourself why. It's a little weird, right? Why aren't they letting us independently explore?
Is Earth the only flat planet, or
so the stars, right? A lot of people think the stars and the lights in the sky are Earth-like, right? So here's what the stars actually look like when you zoom in with a powerful zoom camera, optical zoom, not digital. So it's real zoom. Not only does it show that they're really, really, really close, so this is what NASA shows, but this is what they actually look like. So these are the planets and these are the stars, but they're no different. The only difference between them two is that the planets have their own unique paths. So they're independent from the stars, because the stars are constant. That's why we have constellations.
So if you look through a telescope and you see this,
you won't
seeing?
You won't see this.
You do.
This is what you'll see.
No, I've looked through a telescope. You've seen this.
Yeah.
Yeah.
I would say that you kind of just had like an image in your mind already that's just my opinion. Second, we shouldn't be able to bring these stars into focus if they're supposedly trillions of light years away, or trillions of miles away. They're like 27 light years away, supposedly. We shouldn't be able to bring them into focus like this if they were really that far, but we can. Yeah. So black holes are just theories, in other words. So they're claiming they're observing stuff outside of the Earth reference frame, but nobody can actually go out there to verify if what they're saying is true. So they're just taking advantage of that fact to just make up stories about what's outside to back up the ball Earth claim. So everything about outer space is just CGI and stories. It's not backed by natural science, which is measurable, testable, and repeatable. Natural science shows that the Earth is literally a level plane because the physics of water shows that's literally pushing up, which buoyancy shows that the Earth is literally pushing up. So again, those two simple facts that are irrefutable debunk the entire heliocentric model.
I might have missed the buoyancy part.
Yeah, buoyancy. For example, I was telling her, buoyancy always follows the direction of the force. So if something is less dense than the medium that surrounds it, depending on the direction the medium is moving, that's the direction the buoyant object's going to react. So right here we have a buoyant object. If I accelerate in this direction, if I apply a force in this direction, the buoyant object follows the direction of the force every single time, because that's the direction the medium is moving also through space. So if a helium balloon rises up, that means the air is pushing it up, but what's pushing up the air to be able to push up the helium?
Oh, it's not a force, it's not a push.
Well, buoyancy is a force, which is a push. A push is a force.
It's not pushing on it, though.
The air's not pushing on a helium balloon?
It's the force of the molecules on the surface, on the volume of the...
You could say
itself.
It's the molecules of the air that's pushing up the helium, but the molecules of the air have to be moving up to be able to push up the helium.
They're not actually moving. It's a density difference.
Yeah, it's a density difference, but you require a force to have density differences orientate themselves.
It's not a force in the traditional sense of that being a force.
It actually is. That what you just did right now, it's the only force that exists in nature. Something pushing on something else. If you look at combustion engines, it relies on those principles of something pushing on something else that pushes something else that pushes something else. That's how all engines work. Everything that has motion, it's all push. Could you think of a pulling force? That there is no physical contact between two masses, but one can move the other without any physical contact. I'm sorry? Magnetism? So I was just talking about that in my stream, that's the only thing that people usually bring up is magnetism. But not only does magnetism only affect the metal, but magnets, there is a force there that you can feel. Obviously, when you have a metal object and bring it to a magnet, you can feel that pressure of that. But again, not only does it only affect metal, but in free fall, there is no measurable force of gravity. That's why it's just a theory. That's why Newton came up with his theory, and that's why Einstein came up with his theory. Because all they have is theories. They can only make an explanation of what's going on there because objects don't get pulled down by a force. There is no measurable force in free fall. So like when an object's like this and I release it, there's not something, behind the air that's pushing this down. That has never been measured.
No, nothing's pushing it down. Gravity's pulling it down.
Well, or pulling it, in other words. So a gravitational field has never been measured or detected.
Actually, it has. They have the LIGO detector, that's measured gravity waves.
That's what they say, but again, that would mean that gravity is not a theory anymore because they proved it, right? But the fact is, if you look it up, gravity remains a theory and will always remain a theory.
Yeah, they have the LIGO detector. They also have other gravity wave detectors that are in development and that are out there. They're building one for space now. They're going to do a space-based gravity wave detector.
Right. So here's the thing. You guys, obviously, everybody has a smartphone nowadays, right? Do you understand, or did you guys know that every cell phone or every smartphone has an accelerometer built in? So that's how you're able to put it in portrait and landscape, and it switches based on how you put it, in what direction you put it. Because there's an accelerometer in your phone. That accelerometer detects the presence of a force. So when you have that accelerometer app and you have it here on Earth, it detects 1G. So that's the force of the Earth. But it's a push, not a pull. The reason how we know that is because if you have that accelerometer app and you have it at rest like this, and you accelerate it right, left, up, or down, if you physically accelerate that phone with the accelerometer, it's going to detect an increase in the 1G. It's going to go from 1G to 2, 3, 4, depending on how much force you're applying it, right? Because it detects the force. However, when I have it and I release it into free fall and people claim it accelerates down towards the Earth, it actually detects 0G.
It's because it's relative.
Well, it's not G-force acceleration is not relative. If we actually accelerate something, then that's a physical acceleration.
You are coasting and not accelerating. You're coasting. You're still moving, but there's no acceleration. You don't feel any force.
Because there is no force. Now that's where the explanation of Einstein, for example, the bending and warping of space-time, he claims that, okay, gravity is not a force, but it acts like a force. So they're just double speaking now. So it accelerates matter even though there is no detectable force or acceleration, but because it's not accelerating, but it is accelerating.
They have found the Higgs boson, which is the manifestation of the gravitational force field.
Right. Well, like I said, I've been into this subject over 10 years, and I have never found any empirical evidence that proves gravity to be real. Like that, I'm telling you, that's why Einstein came up with his theory, and it's still the main explanation to gravity, the warping and bending of space-time.
Yeah, but they have proved the effect.
I agree. We can observe an effect, but it's not being accelerated down. It's the Earth catching up to the object in free fall.
Proven the existence of all of the Einstein's theories: gravity lensing, black holes. They've all been proven.
So if I was to ask you, respectfully, obviously, what's the number one proof that makes you believe the Earth is a ball?
The number one?
Yes. Why do you believe the Earth is a ball?
Observations.
Observations of what?
Imagery.
So you're talking about just images of the Earth from space?
That's a very strong, compelling argument.
Okay, sure. Before I get to that, if I showed you an image of me flying, or would you believe I could fly? Just like Superman, with no external components, just me flying like Superman.
Were you just doing this, or were you doing this?
Like just floating in midair, for example. Obviously, I could take a picture of me jumping, but like, let's say I showed you a video of me flying. Would you believe I could fly?
Straight line, so it could have been launched like out of a cannon?
No. Let's say I was literally flying, like floating. You see me a video of me flying, like going up, moving left, right, speeding up, slowing down, and then coming back down. If I showed you a video like that, would you believe I can actually fly?
I believe that something is flying, whether that's
No, but I'm not using any tech. It's just my body, just me, no external components, no jetpacks, no nothing. Nothing external that's giving me extra force. Just my body and me. If I showed a video of me flying like that, would you believe I could fly? I would say that defies physics. Like if somebody showed you a video of an elephant flying, would you believe elephants can fly? Well, obviously, they have to do with the electromagnetic field, obviously, when they flap their wings. Yeah, but there's a cost for that, and we can recreate it.
I would say I would believe it until I could prove it myself empirically through study and through tests.
Exactly. It has to be put to the scientific method, measurable, testable, and repeatable. So again, when it comes to the globe Earth, these images they show us, not only do they admit they're all composite images, they make them in a computer, but all of these images defy physics as well.
Well, not All images.
So this is
there are people on a space station, for example, taking photographs of the Earth in real time. They're not composite
let me ask
images.
you this.
They're using their Sony camera or whatever, and they take pictures.
Do you think it's possible when they're in the ISS that they're using camera trickery like green screens and blue screens, or maybe augmented reality even?
No.
You don't think it's possible that they're... No. How would you know that they're not using any of that?
It's a lot of work. It's not worth
Well, they
it.
do get $70 million a day, so they do basically have an endless budget to be able to...
There are private citizens who are flown in space who don't get that kind of budget, who don't get that kind of money.
Okay. So what? So private citizens are going to space? You're talking about like celebrities and stuff like that? Or?
There have been a variety of them.
Yeah, well... So it's just a consensus thing then, why you accept the Earth as a globe. That's what it comes down to. Because other people claim so, the majority claims so that means it is.
Can we go back to how you said that if bees are flying, then there has to be some sort of...
There's a cause.
What's
Yeah.
the cause?
Well, obviously them flapping their wings. The rate in which they do, obviously they don't fly like birds, you know. They create a magnetic bubble when they have to reach a certain frequency, pretty much, and that's how they're able to elevate themselves, right?
But it's
Who's
physical.
that? That's like
Bees.
bees.
Bees. How do bees fly? Obviously, they don't fly like birds. Obviously,
If there's electromagnetic energy, then there has to be electromagnetic force.
I don't deny the electromagnetic field that's here on Earth. I accept that it exists. That has, yes, but I would say that has nothing to do with gravity or the shape of the Earth. Magnetic.
South, then how would there be appropriate magnetic field for...
Yeah. So the only magnetic field that exists is north. So all compasses point north. No compass ever will point south. They all point north, and the opposite of north is south. So that's how we get south. It's just the opposite of north. So there's no magnetic field. I'm sorry? Well, I don't see what point of that has to do with the globe or not.
Initially you said that there is no magnetic field.
There's no magnetic south. There is a magnetic field here on Earth, yes, but it's coming from the north only. There's only...
Where does it go?
Well, I don't know exactly what the source of the magnetic field is. A lot of people say it could be a giant mountain. You know, I don't buy into that. The globe Earth says that it's a magnetic core, but the reality is nobody knows where that magnetic field is coming from. We know it's coming from a point on Earth, obviously, but nobody's actually been to that point to verify what that is. That's where the restrictions come in of the Arctic. Nobody's allowed to go north or south to fully... No, there's no free exploration here. They have us like animals in a pen, put it that way.
People have been to the North Pole.
Not to the exact north. Nobody's actually took a picture of Polaris right underneath it. It's restricted. Nobody can go there. You gotta ask yourself why.
Magnetic north, the actual spot as measured, does move.
They say that, but nobody's actually been to the north with a compass and go around the center point to show like, look, this is the North Pole.
It's not that precise.
Exactly, because they say it shifts. So that's their explanation to why they've never been to the exact center, because it shifts, right? That's just an explanation. But in reality, nobody's actually been to the exact north, at least in this civilization. Maybe other civilizations have, but from what I'm aware, none of the nations of the UN have gone to the geographic exact North Pole. I'm not saying it doesn't exist. Obviously, it does. I just don't know what it is, what's causing it. You know. So that's just it is. I know you guys heard of flat Earth, right?
Oh yeah.
Yeah. So this is flat Earth is a psyop, and I'm going to tell you why. So the mainstream flat Earth, all the mainstream channels online that are pushing flat Earth, they all claim the Earth is motionless. So they completely deny the fact that the Earth exerts the force. So they're like the globe Earth. They believe that objects accelerate down in free fall as well. So the flat Earth versus globe Earth debate that's happening online, it's a false debate. They both are claiming the same thing.
Okay, well, let's go over that a little bit. So what's the whole sun thing?
So
and the moon thing going
so
over the sky?
Yeah, so when it comes to the sun, the moons, and the stars, all the luminaries in the sky, not only is it a red herring when it comes to the shape of the Earth, because it's completely irrelevant. Looking at the lights in the sky tells us nothing about the geometry of the Earth.
Yeah, but there's no chariot pulling the sun across our flat.
Oh yeah, I would say it probably has to do with the magnetic field here on Earth, how the sun works.
But
there is.
They have probes at the sun.
I actually don't know how the sun works.
They've gone to the south pole of the sun recently and looked at it.
I'm sorry, you were saying that?
There's a new solar probe that just went down to the south pole of the sun and was taking measurements down there.
You're talking about like a satellite that went down to the south, or like?
Yeah. That was not satellite. It's not on Earth. It went to the sun.
Right. If they claimed that, and if they even showed that, I would say I've never heard of that. But if they did, I would assume it has to be some CGI. You know, if they showed video of that. But again, if they just claimed it without any physical evidence, then I would just say it's a baseless claim. You know. But again, how the sun works, how the moon works, you know, all of that, it's completely irrelevant when we're talking about the geometry of the Earth we're standing on. Because again, if the Earth is truly bending or curving, then we should be able to physically measure that curvature like this. Very simple.
But we can't.
We can't.
Oh, yes, we can.
No, because water doesn't have the physical ability to hump in the middle, you know, once it's contained in this.
It does arc with the geometry of the Earth.
But if that was true, then we should be able to measure every lake on Earth bending 8 inches per mile squared, which doesn't happen.
I don't know the exact numbers, but...
Well, based on the radius, this is it. And you could Google it right now. You know, ChatGPT or even AI Google response will show you how much curvature should it be in 3 miles? 6 feet. You could Google it right now. Even the mainstream admits to that because they have to push these numbers. They have to. Because they're supposedly orbiting the Earth with satellites, right? So they need to know the radius of orbit. So they need to know the radius of the Earth if they're supposedly going around it. So they have to give us these numbers.
Have you been to Lake Tahoe?
Yeah, I've been to several lakes. Maybe not that one in specific. But
that's a good example
sure.
of a large lake that
Yes.
you can see across because there's mountains on the other side.
Yeah.
And you can clearly make out stuff that's over there, but you cannot see the shore of the other side.
Yes, due to perspective. If you elevate, then you increase your angle of view and you're able to see the shore.
Yeah, because now the curvature, you get above the curvature, and now you can see down onto the
So again,
thing.
just debating back and forth whether, it's perspective, no, it's the curve. Well, guess what? There's a physical measurement we could do to see if that curvature is actually there. And this will show that it's not there and it's actually just perspective, not
But
the curve
it is
of it.
there.
Well, if you think it is,
You can measure it.
well, I've been in this subject, like I said, for over 10 years, or almost 10 years.
That doesn't help.
No,
prove
sure,
anything.
sure. It doesn't prove anything. My point is that this physical measurement has never been done to show curvature of the Earth. Now, let me ask you this. You're familiar with blueprints, right? So when engineers build like long bridges, for example, in China, there's a 100-mile long bridge, right? All of the blueprints are all going to show that all plumb lines are parallel to each other and all baselines are perpendicular to that. So all of the blueprints here on Earth when it comes to engineering and construction are all plumbs and levels, which wouldn't work on a globe, because on a globe Earth, plumb lines cannot be parallel because all plumb lines are converging to a point. But in reality, all plumb lines are parallel regardless of distance. And you could look at blueprints.
Have you ever heard of a pendulum?
A pendulum?
Yeah, you know how a pendulum works?
Yeah, because it's supposedly swinging, right?
Right.
But if you just have a pendulum,
And you know when a pendulum swings, it starts to precess.
right, they say that that's the spin of the Earth, supposedly.
That is the spin of the Earth.
But again, going back to the geometry of the Earth, whether it bends or not.
But the plumb lines, if they draw it on a flat surface, that's fine. It's an engineering model. But that's not the reality of the model. They took plumb lines out from one end of the thing. It would go straight down here, it goes straight down here, but they're not parallel.
They are parallel.
But
You
they're
can
not.
double check that yourself.
I can.
That's a
I could,
huge.
but-
That'll be a huge flaw in people's engineering work, obviously,
No.
because they
It's
don't
not-
take account of Earth's curvature and they assume all plumb lines are parallel.
But they do. Have you been on a bridge? You notice that there's little separator lines on them. The thing is not one flat surface. It is a bending
I
surface.
would agree that at the ends of the bridge, it kind of does lean back a little bit like this, and that's just to support the structure, and they do account for that. You know, the true plumb on one side of the bridge, we'll say, and then another plumb at the end of the bridge, to say that bridge is 20 miles across, those two plumb lines are going to be parallel to each other.
Not if you took a laser interferometer that could measure those things precisely, it will not be parallel.
It will.
Yeah.
It will. Well, again, at the end of the day, water doesn't have the ability to hump, and you believe it does, but yet you don't have any practical examples, I would say, to show where that logic is coming from, other than images that they show us on TV, and that is why you believe that that's possible. I'm showing actual physics. If you go to, I'm sorry.
How does weather work?
Well, weather, obviously.
Hurricanes that go from them.
Sure, obviously weather has to do with change of temperature, obviously, which is, in my opinion, maybe caused by the sun, the movement of the sun. So the movement of the sun, in my opinion, affects the weather.
You're really scared of dogs.
Oh, okay. No, yeah, they're pretty unpredictable sometimes, yeah.
I did get it.
That's a big dog, too.
But I want to know because there's some hurricanes that'll start, say, over here on this
Sure.
coast. And if we're going to go with the plane Earth theory, then how would this go from here all the way here? Wouldn't it just like peter out like from here instead of just going? Unless it was a good. That's just something for you. I gotta
Yeah.
go.
All right,
I gotta
sure.
go too.
All right, no
It's
worries,
been a
man.
fun discussion.
Yeah, I appreciate
And,
that. Yeah,
good luck
definitely.
with your, I don't know what to call it.
Presentation. I appreciate it, man. You have a good one. All right. Affect people at the end of the day. You guys want to give it a shot?
Yeah.
Yeah, you guys can do it all together. It'll be easy.
Okay.
Yeah, all together, yeah. That way you guys are not singled out. So, two very easy questions. So we'll start with the first one.
Okay.
So here I have 3 box trucks, and there's a bowling ball hanging with the string inside the box truck. One box truck is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3 trucks, which one is at rest?
This one,
Yes. What would you say, Viva?
because it's not moving.
Yeah, obviously it's pretty easy, right? So which one's accelerating forward?
This one,
Yes. How do you know that one's accelerating forward?
it's going backwards. Inertia.
Yes, inertia. So when you accelerate
Ain't
the,
no fifth grader know that.
if you explain it to them, obviously inertia is like a big word, but if you explain it to a 5th grader, this is 5th grade logic. They will understand that, you know, when you accelerate in this direction, the heavier object is going to appear to go in the
Yeah.
opposite direction. Pretty easy. So yeah, due to inertia, you know, the bowling ball you could say is being left behind because it's staying in the same position in space. So the second one is pretty similar, but instead of a bowling ball, it's a helium balloon. So out of these 3, which one is at rest?
That one.
Yes, and it's for the exact same reason as the first one, obviously, because it's not moving. Which one's accelerating forward?
This one,
Okay,
oh, it's C.
it's actually C. Yes, you got it. Why do you think it's C? Why is it C?
Because isn't helium less dense than air?
Yes, yes. But what about the helium being less dense than air? What do you think is happening?
I don't know.
So it does have to do with that. So the reason why is C is because obviously the air is more dense than the helium. So when you accelerate the box truck in this direction, for example, all of the air inside of the truck is also being pushed in that direction because of the force of the truck. So because air is more dense than helium, it's able to push the helium balloon in the same direction that the acceleration is happening.
I see.
So I can demonstrate that here, for example. So that's what we will call buoyancy, when a less dense object gets pushed by the medium that surrounds it, right? So this is a buoyant object in here, right? A buoyant ball. And water is more dense. If I accelerate in this direction, what do you think is going to happen with the ball? Is it going to go forward or back?
Forward.
Yes, it goes forward. Again, because the water's more dense, so it's able to push it in the same direction as the force, right? So I did this experiment real quick in a cargo van. I want to see if you guys can tell the difference. So again, I had a helium balloon tied to a string and an apple instead of a bowling ball. But what direction would you say I accelerated this cargo van? To the right or to the left? Forward.
Right.
Yes, you guys got it. Because not only does matter show you the instant I applied a force, but it also shows you the direction that the force is being applied. So the air, you could say that it's moving in this direction through space, and that's how it's able to push the helium, you know? And again, I did it in a smaller scale, a container filled with water with a ping pong ball that's buoyant and a steel ball. So what direction would you say I accelerated here? Yes, exactly. Because the buoyant object shows you the direction of the force that was being applied. Pretty easy, right? So this last one, I did a vertical acceleration. What that means is that I was holding an object, a water bottle like this, and I accelerated down vertically. So which one of these 2 would you say I accelerated down vertically? The one on the right or the one on the left? Yeah, the one on the right. That's obviously because you can see a change. Matter reacted to the acceleration, right? And this one didn't react at all. So let me ask you guys this. If I have an object like this and I'm holding it and I just simply released it into free fall, but didn't accelerate it, but just released it into free fall, do you guys believe gravity pulls it down to the earth?
Yes.
Yes, right? So they claim a 9.8 meters per second acceleration, right, in free fall. The one on the left was actually free fall, but we see that matter didn't react to that acceleration whatsoever. So I don't know if you guys knew gravity is just a theory. So a physical downwards force has never been detected or measured. So objects accelerating down in free fall has never been proven. So what's happening, right? Well, why does the object go down, right? So what's happening is that since we understand buoyancy always follows the direction of the force, right? If I have a helium balloon here on Earth and I release it, what direction does it go? What's pushing up the helium? Why does it go up?
Because it's less distance than air.
Yes, so the air is able to push it up. Again, in this example, it was the truck that was pushing the air to push the helium. On Earth, what's pushing up the air to be able to push up the helium?
I don't know.
What do you think?
No idea.
It's actually the ground. So the Earth itself is literally pushing up right now, and that's what's pushing up the air, which is able to push up a helium balloon. So the force of the Earth is actually a push, not a pull. So again, when you release an object into free fall, they claim that gravity pulls it down, right? But the reality is, it's the Earth that comes up to the object. So the object didn't move down to the ground, it's the ground that moves up to the object. So that's the reality. So you guys, before you guys go, you guys believe the Earth is a ball, right?
Yes.
So if we could prove physically that the Earth is pushing up, right? Buoyancy shows us that. You guys understand that up is relative on a ball, right? So if you're standing here, up is this way, but if you're standing down here, up is in the opposite direction. In every direction away from the center will be up on a ball. If we could prove that it's the ground literally pushing up against us and not pulling us down, how can the Earth move up in every direction at the same time if it was a ball?
No idea.
Right? It actually wouldn't work. That would mean the Earth would have to be expanding to be able to push up in every direction away from the center, which would mean it would explode, which wouldn't work. So in order for people to believe in the ball Earth theory, they first have to believe in the theory of gravity being a pulling force. Because if we could prove that it's the other way around, that it's actually a pushing force of the Earth, then the whole globe Earth concept falls apart. So that will be the number one proof to debunk the globe Earth, is the fact that gravity is not a pull, it's a push of the Earth. So that's the reason why you're stuck to the Earth, is because the Earth is constantly pushing up on you. And that's why we can't escape the Earth, because it's constantly just pushing up all the time. And that's why we have a buoyant effect here on Earth, is because the air, the pressurized air here on Earth is being pushed up and not down. You know, so that's the reality. So if I was to ask you guys respectfully, what's the number one proof that makes you believe the Earth is a ball? Or why do you guys believe the Earth is a ball?
You can't like see. You can't see everything. Like,
Okay, because you can't see like infinitely,
Yeah.
right? So the I don't know if you guys have heard of perspective. So there is a limit to how far we can see. So
So you think the Earth is flat,
so it's not flat. It's not flat. It's level, and there's a huge difference between level and flat.
but
So
you don't think it's a ball?
no, it's not a ball, 100%.
Okay.
So the fact is, again, the Earth is a level plane, not flat. And I'm gonna tell you the difference between flat and level. And we're all standing, and everybody's up is the same. So orientation here on Earth is singular, not relative. Everybody's up is the same. So flat, the definition of flat, I'll get to the definition, is it's a surface with no bumps or indents, right? It's just a smooth surface. That's what flat would be. The Earth obviously has hills, valleys, mountains, right? So it's not flat. Level, on the other hand, is an orientation, which is horizontal. Level is horizontal, which is perpendicular to the vertical. And the vertical is the force of the Earth. So in order for something to be level, it requires a force. So the Earth is level perpendicular to the vertical, which is the push of the Earth, not a pull. That's the only thing they switched around.
Okay.
So I know you've heard of flat Earth, right?
Yep.
So flat Earth, mainstream flat Earth, is a psyop because they claim the Earth is motionless. So they don't claim the Earth is level because, again, they deny the Earth exerts a force. So again, the Earth does exert a force, but it's just a push, and that's what makes it level. It's the fact that it's moving up, and it's level perpendicular to that motion. So that's the reality. So do you guys have any questions for me before you guys go about this subject?
No,
No?
thank you.
All right, you guys take care.
Good one.